Welcome to Pre-Calculus, Day 28 Notes. Our objective is to perform operations on functions, including the composition of functions, numerically, graphically, and analytically. Okay, given below is a table of values for three functions, f of x, g of x, and h of x. Find each of the following composite function values based on the table of values. Okay, so as you can see, the table's given a little bit differently than ones we've seen in the past. So it's listed horizontally, not vertically. So when x is -2, f of x is 3, so the point on the function f of x is -2, 3. When x is -2, the point on the value of y of g of x is 1, so the point -2, 1 is on g of x. And when x is -2, the value of y on h of x is -1. So the point is -2, -1. Okay, normally we see it vertically. So when you take a few seconds to try to fill in these first six values, um, substitute in, then follow through with whether they ask you to multiply, divide, composition of functions. Um, Try these and I'll show you the solutions and talk through them. Okay, so for the first one, we want to find h of 0. So that's when x equals 0. We come down to h of x. It's 2. Substitute in that value for h of 0. G of -3. Find when x equals -3. And g of x is -2. So now we just go through and multiply. -3 times 2 is -6. Times -2 is positive 12. Now we have division. G of -1. Find when x is -1. G of x is 7. So 2 times 7. F of -2. When x is -2, f of x is 3, so f of -2 is 3. Just leave it as 14/3, don't write it as a decimal. H -2, again, when x is -2, h of x is -1. G of -1, when x is -1, g of x is 7. Please make sure you follow your order of operations, so we're going to multiply first. 3 times 7 is 21, then we combine, doing our addition, -1 plus 21 equals 20. Okay, let's slide down to the next three. So this is just another way of writing h of 2 times f of 2. I think it's easier in writing it in this format. So h of 2 is 3, f of 2 is 5, then just 3 times 5 is 15. Now we get into composition of functions. So instead of having h of 3, we have another function there, f of 2. I probably should have written this one out. So f of 2, every time x equals 2, f of x is 3. And now it's just, instead of h of f of 2, it's h of 3. And we find out when x is 3, what is h of x? -1. So h of f of 2 is just -1. Okay, I wrote it all out on this one. F of -3 is 0, and then we're trying to find g of 0. G of 0 when x is 0, g of x is -2. All right, why don't you guys try the next six? Okay, so let's look at these next couple problems. So composition of functions, h of g of -2. Remember, we always start with the inside function. So g of -2, looking at the chart, is 1. Now we find h of 1. That's going to be -3. G of f of 3, again, start with the inside function, f of 3. Look at your chart. F of 3 equals 2. Substitute in 2 every place you saw the f of 3, and now g of 2 equals 5. And this third one here, h of 1 is -3. And we're finding f of -3 is 0. Okay, the next three have multiple functions, so a bigger composition of functions. I had a student once say this is like a scavenger hunt. So you got to find the inside one and then just keep going from there. So f of 2 is 3, g of 3 is -3, and then h of -3 is 1/2. We would read that h of g of f of 2. G of h of f of -1, so f of -1 is the inside function, that's 2. Then every place you see f of -1, we put in 2, so we get h of 2. Looking at the chart, that's 0. That's when x is 2. What's the value of h of x? 0. Then substitute that in. Now we're at g of 0, and that is going to be equal to -2. So when x is 0, g of x equals -2. And it doesn't matter, the last one, notice it has g of f of g. I could have h of h of h of h of h of 1. It doesn't really matter. So whatever those functions are, you start with the inside function, g of -3 equals -2. Then we get f of -2 equals 3. And now we're back at g, so it's g of 3 equals negative 3. So for the last two problems, we're going to build off of this. They're telling us, they start with, hey, k of x equals 2x plus 10. Then for what value of x is k of x equal to f of g of h of negative 1? So let's find a value for what the f of g of h of negative 1 is, and then we'll go and try to find out what value of x makes that true. So we have k of x equals 2x plus 10. We have k of x equal to f of g of h of negative 1. And we're going to treat that like a system of equations and set those two equal to each other and solve for x. So why don't you try to set that one up? And number n is the same type of thing. Just remember we have an absolute value function. So what's inside the absolute value must equal the number that we get, and it must also equal the opposite of that number. So try those two. I'm going to write them down. You can look at them in a second. Okay, for this first problem, I find out that f of g of h of negative 1 equals negative 4. So I set the 2x plus 10. Oh, I simplify. I think I gave you a different set of notes. So um, you may have this on your chart right here, 2 times x minus 3 minus 4x. And let's see that these match up. Okay, so one set of notes that I have has this function for k of x, and another one has the 2x plus 10 that's listed here. So I'm looking at one of my notes and not at the sheet that I'm given. So whatever one you have, we'll figure it out. If you were given this function, distribute the 2x minus 6 minus 4x equals negative 4, combine like terms, so 2x minus 4x is negative 2x. Bring all the numbers over to the other side, undo subtracting 6 by adding 6, so we get negative 2x equals 2. Divide both sides by 2, x equals negative 1. If we have k of x equals the function that's given here, subtract 10 from both sides, 2x equals negative 14, divide both sides by 2, x equals negative 7. All right, let's take a look at the last one. Okay, so g of negative 2 equals 1, f of 1 equals 4. So if we take our px, absolute value of 2x minus 3, set it equal to 4, so I can set up two functions from that. I get what's inside the 2x minus 3 equal to 4, or 2x minus 3 equals negative 4, because the absolute value of 4 is 4, and the absolute value of negative 4 is positive 4. Okay, now let's go through and solve these. Add 3, so we get 2x equals 7. Divide both sides by 2, and x equals 7 halves. And solving this last one on part 1, page 1, add 3, 2x equals negative 1. Divide both sides by 2, x equals negative 1 half. So both positive 7 halves and negative 1 half satisfy the condition that if p of x equals absolute value of 2x minus 3, then those are the two values of x that will allow p of x to equal f of g of negative 2. Okay, that's part 1, page 1. We'll move on to, I'll have a new video for page 2.